right, everybody. Hello, hello. Welcome back. This is our new unit, first concept. We're going to talk about balancing reactions. All right, so let's review a little bit physical versus chemical changes. Remember that a physical change is a change in a substance that only affects its physical properties, like things like cutting, coloring, crushing, melting, boiling, etc. Chemical changes are changes in a substance that affects its chemical properties. Thus, a chemical reaction occurs and a new substance is formed. Some examples: burning, rusting, decomposing, anything like that. So for the last thing here for a review, chemical reactions are processes by which the atoms of one or more substances are rearranged to form different substances. So let's talk about representing reactions. So chemical reactions are represented by equations, like this one. The front half before the arrow is called the reactants. Those are the starting substances or ingredients. And the second half are called products. Products are the ending substances. That is what is made. So that's the new substance that's created. The little arrow is called a yield, and that's what is produced or produces. So let's go ahead and continue going through our equation here. These numbers in front of the atoms are called coefficients. This tells us the number of each substance needed. These can change. The subscripts cannot change. Please don't try to change a subscript. You can only change the coefficient. If only one is needed, the one isn't written. For example, like chlorine right here. That has no one in it in front of it. That just means there's one of that particular molecule. So if we have two sodium atoms are needed for this reaction, but only one chlorine molecule, that's what that means. So the plus sign separates one or more reactants or products. So you're not always going to get a reaction that only has one product. Sometimes it'll have two, just kind of depends. Some other notations that we can talk about are things that represents the state of matter of each substance. So S is for solid, L is for liquid, G is for gas, and AQ is for aqueous, which means that the molecule is dissolved in water. So let's go ahead and put it all together. So two solid sodium atoms reacted with one chlorine gas molecule yields two solid sodium chloride salts. So that's how you would read that, like a sentence. So let's go ahead and go into balancing equations. So equations must be balanced to keep from violating the law of conservation of mass. So as a reminder, the law of conservation of mass states that matter can neither be created or destroyed. It can only change forms. Therefore, the mass of the reactants must equal the mass of the products. So if there are 50 grams of a reactant, there must be 50 grams of a product. If there are two sodium atoms in the reactants, there must be two sodium atoms in the products. Hopefully you get my gist of what I'm talking about. So let's go ahead and actually jump into balancing equations. So this is why there are coefficients, and we use those to balance reactions. These must go in front of the different formulas or different atoms. Remember, those cannot be changed, but subscripts cannot be changed. So things like that, that's a subscript, that's a coefficient. Please only change the coefficient. So let's talk about the rules for balancing equations. Excuse me. One, you need to write the equation out for the reaction. This may already be done for you, but not always. So we're going to practice both. You're going to put the symbols of each element in a column under the reactants and products. So you're going to keep the polyatomic ions together if possible. And then you're going to count the number of each atom on both sides of the equation and write it in your chart. I'm going to show you what that looks like when we go through some examples. You're going to change the coefficients only on either side of the equation to balance the number of each atom. And then you're going to reduce coefficients as needed. So must be in the lowest whole number ratio. There are no decimal points as coefficients or fractions. So let's go ahead and go through an example. So this is iron and chlorine. A lot of you have not done iron before, but that shouldn't matter when we're balancing, or like a transition metal shouldn't matter when we're balancing. So we have our chart here. This is what I was talking about. This side's for reactants. This side is for products. You're going to go ahead and put the two atoms in the middle. So we have iron and chlorine. There's one iron atom on the reactant side. There is one on the product side. And then this is where you kind of have to think about your subscripts. There are two chlorine atoms. So this tells us there are two of those. And on the other side, there are three. So in order to balance this, the easiest thing to do to start is to even out your chlorine. So you can add a 3 into your reactants. And once you do that, you're going to multiply 3 times 2. So the coefficient times the subscript, that's going to be equal to 6. So in order to make it balanced on the other side, you now have to make it where there's 6 chlorines. So you're going to go ahead and add a 2 in front of iron 3 chloride. And that equals 6. But on top of that, you now have to fix iron. Iron, there are now 2 of them on the product side. So now what you have to do on the product side, you have to do on the reactant side in order to balance it. So there needs to be a 2 in front of the iron on the reactant side, and that should balance everything out. You got to double check, make sure everything's good to go, the same on each side, and then you are done. So 2, 3, and 2 are the lowest, most reduced they could be, so you can't simplify anymore. I haven't ever had to simplify with basic stuff like this. So example number 2, we're going to go from words to words that are given to an actual equation. So you actually do need to remember how to name things and go from name to formula. That's why we've been practicing it so much. So aqueous sodium hydroxide and aqueous calcium bromide react to produce solid calcium hydroxide and aqueous sodium bromide. So this is what it'll look like once you get it all figured out. There's sodium hydroxide, there's calcium bromide, there's calcium hydroxide, and so sodium bromide. Calcium bromide, sodium bromide. There we go. So we're going to go ahead and set up our table with the reactants and products. We have 4 different things. In this instance, since this hydroxide was not broken apart here, you're going to want to keep it together. So that's why you see OH instead of that separated out. And then calcium and bromine, we have 1 sodium on each side. We have 1 hydroxide on the reactants, 2 on the products. We have 1 calcium in the reactants, 1 in the products, 2 bromines in the reactants, and 1 in the products. So we have to start balancing it out. So the best place to start is probably with our hydroxides, which I did here. So in order to balance that, we put a 2 in front of the sodium hydroxide. That means we now have 2 sodiums and 2 hydroxides. So the hydroxide is balanced, but now we have to go to the product side and make it even. So the next best thing is to add a 2 in front of the sodium bromide. So that will give us 2 sodiums and 2 bromines, which is nice because we needed to balance the bromines as well. So this is your finished product right here. So 2, 1, 1, and 2 are the lowest, most reduced they could be. So you can't simplify anymore. And you'll notice there are no coefficients in front of these 2. We don't need them because there's already 1 of them. All right. So here's some evidence of chemical changes to become more important once we get closer to actually looking at different reactions. So the signs that a chemical change has occurred resulting in chemical reaction include things like a release of light, temperature change, odor change, sudden color change, gases given off, sudden appearance of a solid called a precipitate. Those are kind of fun to see actually appear in any sort of reaction. So we're going to go ahead and stop here. We are done with these notes. And then when you come back tomorrow, we're going to have a couple of different activities to do. If you have any questions, definitely let me know and I will answer those for you.